Good morning, dear friends. Last class, I have given problems from continuity. At the same time, how we are showing continuity to the given problems with the help of left hand limit, right hand limit, and function value. With the help of all these three, when we are saying the given functions are continuity, to that I gave one formula, that is LHL is equal to RHL is equal to function value. If all these three equal, then only we can tell the given functions are said to be continuous functions. Like that, we have finished different types of problems. We collected those problems from exercise 5.1. Today also we are going to solving different types of problems on continuity. Let us we are going to starting like those problems from exercise 5.1 here. The first problem, verify the continuity of the function. Verify the continuity of the function. Verify the continuity of the function x power 10 f of x is equal to x power 10 minus 1 if x is less than or equal to 1. So next, x square if x is greater than 1 here. Already in the previous class I told, corresponding to less than which function is that we must consider for left hand limits. Corresponding to greater than symbol, which function is there, we must consider for right hand limits. Corresponding to exact is equal symbol, which value is there or which function is there, we must and should consider those two for function value here. At the same time, we modify this given function at the starting time of solution of this question. How many sides show you now? Solution to this question is, let the given function, let the given function, let the given function f of x is equal to here if x is less than 1, if x is equal to 1, if x is greater than 1 here, like this. Correspond less than 1 function is there, x power 10 minus 1. Exact is equal to, this is belonging to both symbols less than and equal. Let's say exact is equal to 1, we must take this function only, that is x power 10 minus 1. Correspond to greater than symbol, x square is there, that's what we must consider here, x square here. Now we are going to finding values of LHL, RHL and function value here. See here. LHL first, left hand limits. LHL formula is limits x is tending to a minus f of x is equal to limits x is tending to, instead of a they give 1 here, 1 minus f of x is corresponding to less than symbol, which function is there, we must consider for LHL, that is the x power 10 minus 1 here is equal to limits x is tending to 1, x power 10 minus 1 here. Now we are going to removing the limits. When you are going to remove the limit, the variable tends to which value, we must substitute that value in place of variable in the given function, like this. 1 power 10 minus 1, that is equal to 1 power 10, nothing but here we can write 1 only here. is equal to 1 power 10 means 1 minus 1 is equal to 0. LHL value we got 0 here. We got 0. Next, consider for RHL, right hand limit. Limit x is tending to a plus f of x is equal to limit x is tending to a plus means here 1 plus f of x. Limit x is tending to 1 corresponding to greater than symbol, which function is there we must consider here. Corresponding to greater than 1, x square is their function. That's what we must take and we should write corresponding to LHR here. Next substitute here 1 square is equal to here 1 we got. Therefore RHL value is equal to here 1. At the same time, we consider it is equation number 1 and it is equation number 2 here. Same time, I have to find out your function value also. Function values. Function value. Function value is f of x is equal to here x power 10 minus 1. That is f of 1 is equal to exact 1. Exact is equal to 1. They are asking no. In that given function, we must put 1 here. 1 power 10 minus 1. F of 1 is equal to here 1 minus 1 means here 0. That is the 0 here. That's what we can observe. LHL is not equal to RHL is not equal to function value. LHL is not equal to RHL. At the same time, RHL is not equal to function value. That's what we can tell that given function f of x is the not continuous, or we can tell discontinuous at x is equal to 1. Like this. See how means? Here we are getting LHL is not equal to RHL is not equal to function value f of 1. Therefore, the given function f of x is said to be discontinuous or non-continuous. Therefore, the given function is said to be discontinuous or not continuous. Both are giving the same meaning here. Discontinuous at x is equal to 1. Like that we are checking here. Checking of our verification of continuity functions. Check them first. LHL is how much we got. RHL how much we got. And function value how much we got. If all these three equal, then we can tell the given function f of x said to be continuous. But here in this case, we are getting inequality of all these three. LHL is equal to RHLs, not equal. At the same time, RHL is not equal to function value. The time we can tell the given function f of x is not discontinuous. Even in the previous class also, we have finished like all these questions. How we are taking LHL, RHL and function value means, about that I have given definitions of LHL, RHL and function value also. Correspond less than symbol, which function is there? We must consider for LHL. Corresponding to greater than symbol, which function is there? We must consider for RHL. Corresponding to is equal symbol, which function is there? We must consider for function value at indicate exact value. Now let us we are going to solving another questions also here. Next is verify the continuity of the function. Verify the continuity of the function. Continuity of the function. F of x is equal to modulus of x by x. If x is not equal to 0, exact 0 if x is equal to 0. Now we are going to taking the continuity of this function here. They give some variable under the modulus. When you are going to remove modulus, it gives two meanings, plus or minus. Based on that, we are going to giving the solution to this question. If by seeing that function modulus of x by x, it is always represents the definition of signum function. Whether signum functions, whether they are forming continuous or not, we are going to checking now. See, I'll first modify the function like this. Solution to this question is f of x is equal to plus x by x, or if you can take minus x by x, on gets cancelled, we'll get minus 1 if x is less than 0. This is already if x equal to 0 in the given question, they mentioned here 0 here. They gave in the question only. Next one is plus x by x gets cancelled is equal to plus 1 if x is greater than 0. Like that, with help of all these values, now we are going to checking the LHL value, RHL value and function value. Already exact is equal symbol, they gave one value, that's what we can consider it is the function value, that is f of 0 is equal to 0 only here. Now LHL is limits x is tending to a minus f of x is equal to limits x is tending to 0 instead of a they gave here 0, that is 0 minus f of x is corresponding to less than symbol, which function is there, minus 1. Here minus 1 means constant function. The limit of constant function is constant only at any real number. That's what directly we can tell this like this. Limit x is tending to 0 minus 1, and finally we are going to write it here at minus 1. That is LHL is equal to minus 1 here. It is the equation number 1 here. Next, right hand limits. Similarly, in the same way, we are going to finding a value for right hand limit. Right hand limits x is tending to a plus f of x is equal to limits x is tending to 0 plus corresponding to greater than symbol, which function is there, we must consider that only here, plus 1 here, 1. That's why we can write for this limit x is tending to 0 plus 1 here is equal to 1 only. That is RHL. Right hand limit value is equal to RHL here. It is equation number 2. Even function value also exact is equal symbol, which value is that, we must consider that function value here. Function value here. Function value f of 0 is equal to 0 here. But all these three, they are not equal. LHL is not equal to RHL is not equal to function value. That's what we can tell here. LHL is not equal to RHL is not equal to function value f of 0. Therefore, the given function therefore the given function f of x is discontinuous at x equal to 0 here, or we can tell not continuous. Discontinuous or not continuous, both are giving here same meaning here. Even maybe you know about this graph of this signum function. First we say, if we can see the graph also, we can tell f of x discontinuous. How means I will show you now. Says, just we have finished the problems of signum function. Let us now, we are going to checking graph of signum function. By seeing that graph also, easily we can tell f of x is discontinuous. How means I will show you now. Graph of signum function. Graph of signum function. See here, y-axis, that is the x-axis, point of intersection of x-axis and the y-axis called origin, x-axis and y-axis. Here it is the y is equal to 1 here. Here it is the y is equal to minus 1 here. At less than 1 means the line is passing, there is no any stopping to this line. The time we can tell this side only continuous. For greater than 0, y is equal to 1, that is the function value is equal to 1. This side is continuous, it is moving, there is no any break. But if we can mix this, here break will come, there is no any continuous. And moving continuously, move from somewhere continuously here, but it's come down at the same time, and again it moves continuously. As the break is coming between these lines means we can tell this is the discontinuous function. That's what signum function is always a discontinuous function, not continuous at x is equal to 0. One side is continuous, another side is continuous. Because if you can mix these lines, there is little bit some break is coming here. That break is coming means there is the discontinuous function. Then like that, by seeing that is by showing the graph also we can tell the signum function is always a discontinuous function. Let us now, we are going to solving other questions. Verify the continuity of the function. Verify the continuity of the function. Verify the continuity of the function. continuity of the function f of x equal to x by mod x if x is not equal to 0. 0 if x is equal to 0 here. X by mod x if x is not equal to 0. 0 if x is equal to 0 here. Same. Before this, I have given function f of x is equal to modulus of x by x they give. Here x by mod x. Same solution. Similarly, how we solved before this question, similarly same way we are going to giving solution to this question. Now solution to this question is, first you modify this given function f of x equal to x by mod x. First we take minus x is equal to, on gets cancellations, we get minus 1. It is corresponding to if x is less than 0. Exact 0, for exact 0 they gave corresponding to here x is equal to 0. And the one is x by plus x and both are gets cancelled is equal to plus 1 if x is greater than 0 here. X is greater than 0. Now we are going to giving a calculation part for LHL and RHL and function value here. Say here. LHL is LHL value. Limits x is tending to a minus f of x. Limits x is tending to 0 minus f of x. F of x value is corresponding less than symbol minus 1 is there. Instead of f of x we are going to write minus 1 here. Limit x is tending to 0 minus 1. Minus 1 means it's a constant function. That's why limit of constant function is always constant only at any real number. That's what we can write here, minus 1 only. LHL is equal to minus 1. Similarly, in same way, we are going to give a proof or to calculation part to LHL value. RHL, right hand limit. Limits x is tending to a plus f of x is equal to limits x is tending to 0 plus corresponding to greater than symbol. Which function is that? You must take that only 1 they gave. That's why instead of f of x we are going to write 1 here. Is equal to limit x is tending to 0 1, that is limit of any constant is constant at any real number. According to that point we can write here or value for origin is 1, that is right hand limit value is equal to 1 here. It is the equation number 1 is this, and it is the equation number 2. Next, function value. Function value. Exact correspond is equal symbol they gave value to 0. That's what we can write here. F of 0 is equal to 0 here. This is equation number 3. Therefore we can write LHL is equal to RHL is equal to F of 0. Therefore the given function the given function f of x is said to be discontinuous at x is equal to 0. Like that, we are showing f of x is whether continuous or discontinuous. First, we found the value for LHL minus 1, and second, we found the value for RHL plus 1, and finally, we got the value for function value, or function that is the 0 we got. And comparing all these three, but they are all those three are not equal. That is, LHL is not equal to, RHL is not equal to, LHL is not equal to, RHL is not equal to function value. That's why the given function f of x is to be discontinuous. Now let us, we are going to solving another questions now. Verify the continuity of the function. Verify the continuity of the function. Verify the continuity of the function. Verify the continuity of the function f of x is equal to x plus 5 if x is less than or equal to 1. X minus 5 if x is greater than 1. Same, and before this we solve like all these questions we solve now. Same solution we have to apply here also. And before giving solution to like all these questions, first we modify the function first. Less than correspond less than symbol, which function will come here? Correspond to greater than symbol, which function will come here? Exact correspond is equal symbol, which function here? Like that, we have to discuss. We must write about all this here. Solution here. Solution to this question is solution to this question. At the given function f of x is equal to here. If x is less than 1 and which function? If x is equal to 1, correspond is equal to which function here? And if x is greater than 1, like this. Less than 1, x plus 5 is there. X plus 5 here. Correspond is equal to 1. It is applicable to both symbols less than and equal. Corresponding to is equal symbol, we have function here x plus 1. Correspond to greater than symbol, one function is there, that is x minus 5 here. With the help of all these things, now we are going to finding values of LHL, RHL and function value here. LHL is left hand limit. Limit x is tending to a minus f of x is equal to limit x is tending to 1 minus f of x. Limit x is tending to 1 correspond less than symbol, which function is there here? X plus 5 is there. Now you remove that limit symbol. When removing that limit symbol, that variable x tends to which value is there, we must substitute that value in place of x here. That is 1 plus 5 is equal to 6 we are getting here. That is LHL value is 6 here. Next, we are going to giving solution for RHL and function value also here. See here. RHL, right hand limits. x is tending to a plus f of x is equal to limit x is tending to 1 plus f of x. F of x means corresponding to gradient symbol. Which function is that? We must take that here. That is x minus 5. Next step is limit x is tending to 1 x minus 5. Now afterwards remove that limit symbol. When you are going to remove the limit symbol, that variable extends to which value is there. Instead of x, we are going to putting that value only here. Like that, we can proceed solution to this RHL. Then we get here 1 minus 5 is equal to minus 4. We can write this as the RHL, right hand limits. This is we represent LHL for equation number 1 and RHL for equation number 2 here. And finally, you must find out here function value here. Function value. Exact is equal symbol. Corresponding to exact is equal symbol, which function is there? Your x plus 5 is equal to 1. That's why instead of that function, instead of variable of that function, we must put here 1. f of x is equal to x plus 5. In this case, put x equal to 1 here. F of 1 is equal to 1 plus 5. F of 1 is equal to 6 here. Is that? LHL is not equal to RHL. At the same time, RHL is not equal to function value. That's what easily we can tell that given function f of x is the discontinuous function. Therefore, we can write here LHL is not equal to RHL and RHL is not equal to function value f of 1. Therefore, we can write the given function f of x is said to be discontinuous or not continuous. Not continuous at x is equal to 1. X is equal to 1. Like that, we are giving a solution to this question. Like that, today I have finished different types of problems on verification of continuity with help of formulas of LHL, RHL and continuity. Next class also we will solve different types of problems on verification of continuity with the help of formulas LHL, RHL and function value. After completion of that, we will solve the problems on constant functions. Just they give only constant functions. They are not giving any variables. At a time, how to solve LHL, RHL and function value. And after completion of all this, with help of given conditions of continuity, we are going to finding unknown value from the given problems. Like that, we will solve different types of problems on next class. Thank you very much.